Hello friends, in today's class we are going to talk about LRU approximation algorithms. So welcome here, and we are talking about this LRU approximation algorithm because LRU needs special hardware. Okay, to implement the true LRU we need a special hardware in terms of let's say few bit registers. Okay, in terms of registers we need this hardware, and hardware can be also in the form of let's say register, or you may need, in some cases we required a comparator. So this all hardware support is needed for this, and still slow. Okay, so one of the concepts to implement this LRU approximation algorithm is by using a reference bit, not a true LRU but LRU approximation. So with each page we associate a bit, and initially it is a 0, and when the page is referenced then the bit is set to 1. Okay, so initially all the bits are 0 and then it is set to 1. Replace any page with reference bit is equal to 0 if 1 exists. Okay, so we'll replace it, but the problem here in this case is if I replace any page with reference bit 0, then we simply don't know the order. So we really don't know the order in that case, and that is not exactly what LRU does. This is the second approximation algorithm, the second chance algorithm. Okay, so the second chance algorithm is a FIFO, and that means this algorithm is first in and first out. So this is the only logic that it is implying, the first in and first out logic. Okay, plus hardware provided reference bit. So it is FIFO plus, okay, this is combination, that it is first in first out plus hardware provided reference bit. Okay, so hardware provided reference bit. Okay, now clock replacement. Clockwise we will going to replace. If the page is to be replaced, then the reference bit should be 0, then replace it. Okay, if the page is having a reference bit, then that is also in the previous case, reference bit is 0, and then what does it mean is then just replace this page, replace it. If the reference bit is 1, then set the reference bit to 0 and leave the page in the memory. Okay, so that is the second chance that is being given, that if it is 1, okay, if it is 1, if the reference bit is 1, then set the reference bit to 0. Okay, give one more chance to it and leave the page in the memory. Replace the next page subjected to same rule. Okay, the same rule we applied. So now what we are going to do is we are going to maintain a bit and we'll give the second chance to it. Okay, we'll give the second chance to this algorithm, second chance to this memory page. Okay, so now this is the implementation of it, and if it is 2, and we will set the reference bit to 0 for this, and then 2, then 3 will come, there will be page fault, true 3 2. Okay, so in the third chance what will happen, 2 3, but this time it is referenced, and hence this bit will be set to 1, and this time it is not referenced, so this bit will be 0. Okay, so initially it was 0, and here it is referred one more time, so that bit is set to 1. 2 3 2 1, and it is not been referred, so that will be 0. 5 comes, 5 comes. So now we will, when 5 will come, then we will search this in FIFO order, first in first out order, and first in first out order is 2, and what is my logic says over here in this case is that you are going to have a reference bit 0, then replace it. If it's a reference bit button, set the reference bit to 0. So in this case what we'll do, that we'll set it to 0, and then we'll come to this 3. Okay, and that will be replaced. Okay, so that will be replaced, and that will be replaced by 5, setting the reference bit to 0, 1 and 0. So here the next is in this case is we are done with up to this, and again 2 is coming, And because again 2 is coming, now what will happen, that 2 reference will be again set to 1. 5 remains 0, 1 remains 0. Now 4 comes, and here the reference bit is 1, so this will get the second chance, but this reference bit will get to 0. And 5 and 1, who came first? Okay, among 5 and 1, this is FIFO plus hardware support as the reference bit. So both are 0, and here right now 5 is here and 1 is here, and that means that 5 will not be referred, and this 1 will be gone, and 4 will be loaded into this reference bit 0. Again 5 is coming, when the 5 will be referred, then the next part what we're going to do, 2 0, and 5 reference will become 1, and then 4 0. Next part is your 3. So when 3 will come, we will have this 3 will come. Then in that case, now we will see that 5 reference bit will remain, will go to 0, but we will not replace this one. We simply make it 0. And among this 2 and 4, there is a 2 and 4. So 4 is just recently referred, and before that this 2, the first who came first, 2 came first, so 2 will be gone first in this case. So 3 0, and in this case 4 0. Next comes the 2, and all of them are 0. Who arrived first? So 3 5 and 4. Okay, this is the order, 3 5 and 4, and 4 will be replaced here in this cases. 3 will remain 0, 5 will remain 0, and here who arrived first? 4 arrived first, so 2 is going to replace this. 5 is a hit, so 3 0, it will become 5 1 and 2 0, and we'll give it second chance, and again 2 comes, and that will become 3 0 5 1, and this 2 will also become 1. Okay, so second chance algorithm is again repeating the logic that if it is 0, then replace it. If this reference bit is 1, then set this reference bit to 0 and leave the page in the memory. Do not replace it. Okay, every page will be subjected to this reference. Okay, and whenever you have more than one reference bit, okay, reference bits as 0, then we'll break the tie by first in, first out, right? So that way we break the tie. So we are here circular queue of the pages, and second chance will be just not just the diagram is suggesting only one thing, that this is a circular queue where in the order we are maintaining this queue. Okay, we'll maintain this queue, and this reference bit will be set to 0, this reference bit will be set to 0, and this is the next victim. Okay, so this is going to replace the page. Okay, so I hope it is clear to you. The next one is the enhanced second chance algorithm, that we improve the algorithm by using reference bit and modified bit. Okay, so now we are maintaining 2 bits information we are maintaining. So what is this information? One is the reference bit and modified bit. Okay, if available, take the ordered pair referenced and modified. Okay, now if it is neither referenced nor modified, okay, neither referenced nor modified, then the best page to replace. It is not even referred and not even modified, so old page is there. Not recently but modified. Previously somewhere it was referred, but it has been modified. Not quite as good, but must write back on the replacement. We have to write it back into the disk. 1 0 is recently used but clean, probably will be used again. And finally, if it is referred as well as modified, recently used and modified, probably will be the used again soon and need to be right before the replacement. So many big task is there. So best page is what? 0 0 is the best page, not referred, not modified. Then we have 0, 1, not referred but modified, maybe not used in the longest period of the time, just referred but not modified, maybe used again, and 1, 1 is recently modified, recently used and modified. So this is this may be referred again in the future, and that way we can say that this should not be used. This should not be replaced. Okay, so that is your enhanced second chance algorithm. But see, maybe this figure may be bothering you, but this is the cue for maintaining the order, and next victim will be, in this case, will be 0. Okay, 1 will be set to 0, one will be not referred, 1 will be set to 0, another 1 will be set to 0, and the next 0 is going to be replaced. Okay, but the set will give you the entire correct idea that what and how should it work. The last thing is your counting algorithm, and we keep a counter on the number of reference that have been made to each page. Okay, it is not very common to use here in this case, but we are maintaining a counter for each page. And least frequently used page, LFU algorithm, replaces the page with smallest count, and most frequently used algorithm is based on the argument the page with the smallest count was possibly just bought and has yet to be used. Okay, so that is the two idea. That is your counting algorithm. Okay, so least page, least recently used, replace the page with the smallest count, and most frequently used is the replace the page with the just bought, that is smallest count and yet to be used. Okay, so that's all for this discussion of LRU approximation algorithm. We are not able to implement the true LRU, but we have some hardware support, and with that we can implement the LRU algorithm. Okay, so that's all for this discussion. Thank you.